Hello, everyone. If you're here waiting for this webinar, bear with us. We're just going to let everyone give it another minute or two for everyone to join, and then we'll get started. And I'll do some introductions and stuff. Hi, everyone. Just another note. We're going to give it another minute before we get started and just let everyone get in the room. So you haven't missed anything yet. We'll give it another minute or two. I can still see virtual people streaming in. So we're scheduled to start at 1 o'clock. It's 1 o'clock now. Given that I'm always late, I'm going to give another minute or two for those Sean-like people out there who are always a minute or two late. Okay. We're a couple minutes past 1. Why don't we get started here? So, welcome everybody. My name's Sean Brillant. I am a senior conservation biologist with the Canadian Wildlife Federation, and you are here joining us for our third live webinar on North Atlantic right whales. And this is a collaboration between the Ocean Tracking Network and the Canadian Wildlife Federation. And we were really interested in trying to find an opportunity to inform everyone about what the situation is around right whales and the work that's being done. And that's what these webinars are all about. So before we get started, I know we have people from across the country or across the continent who are going to be tuning in, but I want to begin by acknowledging that we are hosting this live stream from Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people, and acknowledge that we're all treaty people here and have those benefits. Canadian Wildlife Federation and the Ocean Tracking Network have organized this series to talk about this critically endangered North Atlantic right whale. We do want to note that since 2017, the Ocean Tracking Network has been partnering with Big Spruce Brewing Company in Cape Breton to produce an IPA called Tag Your It, and they use sales from this beer to support research on marine conservation initiatives. And this year they're supporting work on the right whale. And since it launched on Earth Day, more than 50,000 cans of this beer have been sold to support this work. So it's very encouraging work, and we just want to acknowledge that. Today I have, for your pleasure, we've invited Kimberly Davies to join us in this talk. Kim is a graduate of Dalhousie University, and she is a professor at UMBSJ in St. John, New Brunswick now. She is a biological oceanographer who's spent lots of time at sea, and has worked here in the Maritimes as well as in France and in other areas as well, studying the way the ocean works and how that interacts with the different things that live in the ocean. And Kim spends quite a bit of time focusing on right whales as well. So we have her here today to spend time with us, with me, chatting about these things. We are going to open this up for questions. Kim and I are going to have a discussion for about a half hour and fill you in on the work that she does and a little bit more about right whales and what this is all about. If you're watching us on Zoom, you can submit your questions in the Q&A box located at the bottom of the screen. And if you're watching on Facebook Live, you can leave your questions in the comment sections below the video, and we will try and get to some of those questions in about half an hour. Great. Sound good? Wait, let me make sure I've said everything that I'm supposed to say. Great. Okay. Hi, Kim.
Hi, Sean. Thanks so much for having me. And it's nice to see it. We've got some people from landlocked Alberta and from Bothic territory. So yeah, looks like we've got people from all across the country. So hi, nice to meet everyone.
Thanks for joining us, Kim. This is really great. I appreciate the chance to do it, and we have a chance to talk fairly often about right whales anyway, and this is just a chance for us to kind of invite people into some of the discussions that we have and bring everyone up to speed on what this right whale situation and what right whales are doing in our oceans as well.
Mm-hmm. Yeah.
Yeah, let's chat about this. And you have great insight into these things, so I'm really glad that I have you here to answer a lot of these questions. We have done a couple of other webinars on this, and I've had a chance to talk to people about right whales and the issues they're facing quite a bit, and when we talked about necropsies and everything else, but I was really looking forward to having a chance to talk to you about the whales themselves and how and why they use the ocean, and you've got a lot of knowledge about this. So I don't know, let's start with that. I mean, these right whales come to Canada every year to feed, is what we're told and what we know, but you know much more about this than most. So what can you tell us about that?
Yeah, so I started to study right whales back in 2007 when their population was increasing. And back then, I did my PhD research on a little place called Roseway Basin on the Western Scotian Shelf, just off of Yarmouth in Nova Scotia there. And they were really abundant in this little continental shelf basin. And the continental shelf around Atlantic Canada is pretty shallow. You know, it's around 100 to 200 meters. It's got hills and valleys. We call them banks and basins. Right whales like basins, and there's a good reason for that. So we used to find them a lot in Roseway Basin and also this place in the Bay of Fundy called Grand Manan Basin. And we found them there because the oceanography in these basins is such that their preferred food, a tiny little copapod called Callanis Finmarchicus, collects in these basins. And these basins have currents that are sort of recirculatory, like gyres. And so even though these plankton are floating in the water, right, they're in the water column, the currents keep them sort of constrained inside of these basins. And so back then, these areas they're these sort of fairly tiny habitats relative to, you know, the ocean on our continental shelf in Atlantic Canada. And when I say tiny, I mean, you know, maybe like 10 by 30 kilometers, like pretty small. So the whales would be really concentrated in these areas. And that was great. And I did my studies and I found that there was lots of food energy available in these habitats. These copepods are very lipid rich. So they're really, really nutritious food resources. And then something happened just before I graduated with my PhD. Right whales all of a sudden left the Bay of Fundy. And this was super unusual because right whales had been there consistently every summer for 30 years. And there were lots of research programs that sort of relied on these animals being there, right? It's a coastal area, super easy to access. And so there's a lot of research on this habitat. We knew a lot about it. And all of a sudden, one year, gone very abruptly. And that's when things started to change and we started to need to ask bigger questions about what was going on in the oceanography around in the Gulf of Maine, Bay of Fundy region.
So the copepods, these are basically bugs. They're very small, about the size of a grain of rice or so, and they're essentially a bug. They're a type of crustacean, eh? And they're found everywhere in the ocean, right? Like,
yeah,
these are,
well, not this particular species. It's not found everywhere, but these bugs, these copepods are found everywhere.
yeah.
This particular copepod is found primarily in the North Atlantic.
Right.
And you don't find it really very far south of the Gulf of Maine. It doesn't like warm water. So you find it in the cooler, temperate, and subpolar regions.
Mm-hmm. And these things are present year round, right? They do grow year round, don't they?
Yeah, they are present year round, but they don't grow year round. Right. So in the waters around Atlantic Canada, they experience seasonal changes in productivity, just like on land, right? We have spring where, the grass starts to grow and our gardens start to bloom. We have summer when everything is sort of very warm and in full bloom. And then we've got a period of senescence in the fall. Right. The same thing happens in our oceans. We have phytoplankton being the base of the food chain in the ocean. And when conditions start to warm up and calm down from winter in early spring, we get strong phytoplankton blooms happening in the ocean. And these Callanis, Finmarchicus, these copepods, they need this phytoplankton bloom in order for them to start reproducing. So we have a giant bloom of this food resource of the whales in the spring. But the spring isn't the time when the whales are actually here feeding on these copepods. They need to wait for these copepods to grow and become lipid rich. Right. So these copepods store lipid inside their bodies in order to, just because at the end of the summer, they're going to go into hibernation, just like a bear does, right? They put on fat. So in addition to growing and reproducing and using this spring bloom food for growth and reproduction, they also pack on lipid. Right. I've actually got a picture showing the lipid sac. Did you want to see that?
Yes.
Okay, I'll
right way. So these are basically these little tiny bugs form a big droplet of oil in them. So they're like high density food, eh?
Yeah. Can you see my cursor?
Yeah.
Yeah. So here's a Callanis Finmarchicus copapod. It's about 1 millimeter big. So it's the size of a grain of rice. And this is a mature individual. And inside of it here, you can see this is its oil sac. And that oil sac makes up about 80 to 90% of its nutritional quality for right whales. This on the right is a sample that I pulled up out of the Bay of Fundy last year. So each one of these tiny little transparent looking grains of rice here, that's a Callanis Finmarchicus copapod. So they're teeny tiny. And you can see the scale bar here. This is a shrimp. So they're much, much smaller than shrimp. Yeah. And right whales are filter feeders. They have very, very fine baleen. So they're one of the only whales that can actually exploit these tiny rice-sized copepods. The other baleen whales tend to go for larger organisms.
That's right. And we should mention that. People tend to think of whales as, people always hear about whales eating krill, for example. That's not always the case. They do eat krill. And these right whales, unusually enough, eat these things which are even smaller than krill. They're these tiny, tiny little droplets of oil. And they somehow have this device in their mouth that allows them to get enough energy from the water to feed on these. It's amazing. It's so dense there. It looks pink, right? That sample that you brought up.
Yeah. So the copepods are ubiquitous, but the whales won't just feed on these copepods anywhere. They need these really, really dense concentrations of these copepods in order to get enough food energy in a mouthful of copepods for it to be nutritious enough for them to get their daily energy. So right whales will concentrate in these very sort of constrained areas of ocean where the currents and the phytoplankton abundance and the zooplankton abundance are all super productive, and the currents can constrain them into these really, really dense patches. And that's why you kind of don't get whale habitats occurring everywhere. They occur fairly persistently in the same spots from year to year to year, because you get you need these very specific conditions to get these aggregations in the water column.
Right. So these are plankton. People have probably heard of plankton. These are zooplankton. So they're like tiny, tiny little animals. They do swim, but it's not like these little bugs migrate, right? Like they're not like moving large areas. They tend to be moved by the ocean currents and features, eh? And I guess that's what's important, to make these patches that the whales home in on. That's really.
Yeah. So the ocean is not like a bathtub. The ocean has variations in temperature, in salinity, and these variations will drive ocean currents, the generation of ocean currents. You can imagine that the waters in the Arctic are colder during times of year. They're fresher. Waters from the south tend to be quite a bit warmer. They tend to be more salty, and then you have these large scale current systems that are moving these different water masses around. And some of we call these water masses, discrete bodies of water that have, particular biological, physical, chemical properties. And I'll just show you. So right whales, it turns out, their habitat is really, really dependent on what kind of water is in an area at a particular time. And our climate right now is changing, right? And so we have this sort of warming trend happening in ocean waters. And it's causing these ocean currents to change, and it's causing these water masses to redistribute themselves. And what's happened in the Gulf of Maine and the Bay of Fundy and the Scotian Shelf, this is an area where right whales used to feed. This area has warmed throughout the water column, not just at the surface, but also at depth, because the water masses have changed. So I've got a little figure here. If I can share my screen again, just sort of showing this principle here. Yep. So what's happening here, what you're seeing on the left are these arrows representing major current systems in the North Atlantic. So we've got cold water coming out of the Labrador Sea. Here's Newfoundland, here's the Scotian Shelf, and here are these two right whale habitats, Roseway Basin and Grand Menam Basin here, and then here's the Gulf of Maine. So usually we would get a lot of water out of the north, and this area is very productive for Callanis Finmarchicus. And these Callanis Finmarchicus will get carried in these water masses by currents into the Gulf of Maine, creating really good habitat for right whales in the Gulf of Maine. In 2010, I told you something changed. The right whales, they moved away from the Gulf of Maine, including the Bay of Fundy. And what we think has changed has to do with this white arrow here. This represents a major current system called the Gulf Stream, which people have probably heard of. It comes up from the south as a current jet. So it's relatively very fast normally. Mm-hmm. Over the last 10 years or so, it started to slow down. And as it slowed down, you can imagine like when a river slows down, it can start to meander, right? And spread. Mm-hmm. And so this on the right represents the track, the dark red represents the track of the Gulf Stream prior to 2010. Right. And then this transparent red area indicates this meandering and spreading of this water mass after 2010. And the Gulf Stream is very, very warm water throughout the water column. Mm-hmm. So what we have now is these warm water intrusions into the Gulf of Maine throughout the water column, which make it very unfavorable for Callanis Finmarchicus. Right. They don't like really warm conditions. They won't grow in those conditions. They suffer high mortality in those conditions. And that water mass, that Gulf Stream water mass, isn't a place where those animals are going to be thriving. So we think that this has explained why over the last 10 years, we haven't had right whales in the Bay of Fundy or in the Gulf of Maine during spring and summer.
Right. And it's not even necessarily that these copepods have left. The conditions just aren't right for them to grow there anymore.
Yeah.
And conditions might be temperature, or they might be the oceanography, the movement of this water, and all of a sudden it's not collecting them in a high enough concentration for the whales, eh?
Yeah, and that's the big challenge for oceanographers, is trying to figure out what is the transport effect versus what is the production effect on this whale prey.
Right.
Yeah.
So the other thing I just want to mention too is that they tend to aggregate, concentrate into these basins, into these two areas that are bowls. There are lots of bowls along the Scotian shelf, though. Do these copepods, do you know if they aggregate or concentrate into these other bowls as well?
Yeah, they absolutely do. But the other bowls are quite deep.
Yeah.
And right whales tend to be quite shallow divers.
Mm-hmm.
And so one hypothesis is for why we don't see right whales in some of these other basins on the shelf is that they just will not dive that deep to get to these very deep layers of copepods. The other hypothesis is that the Bay of Fundy is well known for being for having the highest tides in the world. And you need these really strong currents to actually concentrate the prey into patches. Mm-hmm. So the Bay of Fundy could have unique conditions, unique currents that help to concentrate these plankton in the way that some of these other basins don't. So again, this is another challenge of oceanography to try to figure that out.
So let's give a bit of context here. You say these whales tend to dive. They're not willing to dive too deep. So how deep will they dive into these basins?
They tend to dive not more than 200 meters. They're capable of diving deeper than that, but they tend to only dive down to 200 meters.
Right, diving down, that takes a lot of energy. They've got to hold breath. They're very buoyant. They've got to try and swim their way down. They go much deeper than that. It just doesn't make sense, eh? I guess is what it's coming down to. But 200 meters, that's amazing. But interesting that they don't seem interested in going much deeper than that for the food. So it seems what they'll do is they'll go look for it somewhere else, eh?
Yes. And so back in 2010, things started to change and the whales disappeared. And for 5 years, we had no idea where they were. They were lost. They were gone. We couldn't find them anywhere. I mean, there wasn't a huge amount of survey effort for right whales in Canadian waters prior to 2015 when the animals started to turn up in the Gulf of St. Lawrence and we started to have mortalities there. Prior to that, we didn't have any aerial surveillance at all in Canada. So there were no airplanes out looking for them.
Right.
And we didn't really have any monitoring programs outside of the Bay of Fundy. So it was a huge effort just to figure out how to get money and resources and people and eyes on the water and ears underwater listening for these animals, because they're very rare, right? We're talking about trying to find, 400 animals in a huge area of ocean. Mm-hmm. So they were lost. And so what we did was we said, okay, well, we know something about these oceanographic conditions that we think are good Callanis habitat. Let's target some areas to the north where we think Callanis would still be surviving, even though we've got this process in the Gulf of Maine that's maybe not very suitable for them. Right. And then we started looking hard at the Gulf of St. Lawrence. And we identified a couple of areas that we thought would have these conditions and sent NOAA, working with NOAA in the US. They came up and sent a plane with some right whale specialists out and discovered one of these areas in the southern Gulf of St. Lawrence in 2015. And that's when the game changed completely.
Federal agency in the US, National Oceanographic and Atmospheric Administration, and they came up and flew some of the initial surveys. So these conditions, though, that needed to find, they're basically the same conditions that you were looking for along the Scotian Shelf and in the Bay of Fundy, right? I mean, it's a basin, it's a kind of a deep area, a convergence of appropriate currents that can concentrate these copepods, and that's kind of what you ended up finding, right?
Well, In some ways, in some respects, the new habitat is very similar, and in some respects, it's very different. So I just want to give everybody a little bit of context here about a little bit of geographical context. If you can see my screen here. Can you see my cursor?
Yes.
Excellent. So here on the left, we've got each whale tail represents a sighting of a right whale. And on the left, you've got the right whale sightings before 2010. And on the right, you've got them after 2010. And you can see here in the spring and summer, right whales were really concentrated in this sort of these known traditional habitats. And then after 2010, we find, well, this is really after 2015, we find this enormous aggregation, really quite significant in terms of the spatial area. In a place called the Southern Gulf of St. Lawrence. And so here's Prince Edward Island, here's the Gaspé region of Quebec, here are the Magdalen Islands. And this area is very shallow. It's, you know, where we're finding the right whales now is much more shallow than in the Bay of Fundy. 50 to 100 meters is sort of the bottom depth in this area. It's also extremely cold there. The water is 0 degrees year round below sort of the surface mixed layer where you would get like some seasonal warming from the sun. Below that, you've got what we call a cold intermediate layer. So it's 0 degrees year round. Wow. And because it's 0 degrees year round, it can not only support Callanis Finmarchicus, it can actually support some of the Arctic copapod species that are close relatives of Callanis Finmarchicus. Right. And so now we get other kinds of lipid-rich copepods being part of this habitat and part of the right whale prey field that we never knew about before.
Right. And the whales are presumably taking advantage of both. I mean, if one field has dried up where they can't seem to get this food anymore, I guess they are able to diversify a bit, right? These are all similar kind of bugs. They may have some preferences, I guess, but.
Yeah, they are similar. They are similar enough in that they produce lipid. They have this sort of similar life history strategy where, you know, the lipid is produced to cope with these long seasonal periods of low food supply. But in other ways, they are distinct. Right. And so some of these species peak at different times of year. Where we used to only get right whales in summer in Canadian waters, let me say that again. Right whales in Canadian waters in summer. Now they're here from June all the way to November. And that's because they're feeding on multiple prey species now. Right. And these species are peaking at different times of year, so they can stay in Canada for a lot longer. And that means we have to pay attention to their conservation for many more months than we used to. We used to just kind of worry about them in July, August, September. Now we're worried about them from sort of mid-May all the way through to December, really.
Have I lost you, Kim?
No, I hear you, but your video is frozen. Is my video frozen?
That's frozen.
We can still see you just fine, Kim.
So was it a Sean problem?
It looks like we're having a slight technical difficulty on Sean's end. So Sean, if you can still hear us, perhaps log out and log back in. We can still see you, but we're not hearing you. So everyone, for the slight technical difficulty, we're going to get things right back up and running in a moment. And while you're waiting, if you'd like to leave your questions in the Q&A box at the bottom of your screen, please feel free to do so because Sean and Kim will be answering some of your questions shortly.
I mean, I can keep talking to myself. I could talk to myself about this stuff all day long.
Here's a thought, Kim. We do have a few questions that have come in. Perhaps I can let you know some of the questions. And
sure, I can answer a question while we're waiting for Sean.
Yeah, that sounds good. All right, so we've got a question here from Paul. And Paul wants to know, what do you feel are the things we need to do in order to not only preserve the population, but increase their numbers?
That is an excellent question. It's probably the most critical question in right whale conservation at the moment. So something that I hadn't gotten to yet is that right whales, since they shifted their distribution into the Gulf of St. Lawrence, concurrently, they have had a significant decline in calving. So that indicates the population is nutritionally stressed. They probably rely on the Gulf of Maine being very productive in order for them to gain enough energy to produce a lot of calves. So it's especially important right now that because calving is very low and it's been low for 10 years, that we protect every individual, especially every breeding female, because there are only about 100 breeding females left in the population. So in order for this population to start producing again, the oceanography is going to have to get a little bit more favorable in terms of the productivity of its food. And if we've killed all the breeding females by the time that happens, then there's not going to be an ability to recover from this long period of low food supply. And the way that we need to do that is to protect these animals from ship strikes and fishing gear entanglements. Sean and I work very hard with a lot of partners in industry and government on various strategies to achieve this, from designating areas where ships are not allowed to go, like that habitat that I showed you in the Gulf of St. Lawrence where there was lots of whale tails. This year there was a ship exclusion zone around that area, to speed restrictions in certain areas that are higher risk. So there are some shipping lanes that go through the Gulf of St. Lawrence, connecting Toronto and Montreal to Europe and New York. So these are major shipping lanes for cargo, for tanker traffic, for cruise ship traffic. And so Transport Canada has implemented some speed limits in these lanes to try to reduce the likelihood that a whale would die if it was hit. On the fishing gear entanglement side, there's a variety of different strategies, and Sean is really the expert, so he can talk more about the different strategies, but essentially trying to reduce the amount of line in the water, changing the fishing seasons so that they don't overlap with the time of year when the whales are here, having areas that are closed to fishing, and moving from towards safer forms of gear, what they call whale safe gear. So there's lots of different strategies. There's no one sort of unifying approach that is going to fix the problem. It's really going to be a multifaceted approach to reducing human-caused mortalities in the species. Yeah.
That's great. Thank you so much, Kim. I know it's a difficult problem for sure. We've got a lot more questions coming in, so I'm going to jump to another one.
Sure.
We have a question here from an anonymous attendee. How do you think right whales find and communicate copapod densities that have been moving as a result of climate change? Their departure from Bay of Fundy suggests that they don't simply follow tradition with regard to feeding grounds, but can react to changes and find new feeding grounds.
Mm-hmm. Yeah, that is an unknown, really. We don't know exactly how they find their feeding grounds, whether they have some ability to sense, certain water masses or chemicals in the water that might help them trace good foraging conditions, or whether they're just searching around in the dark. I mean, they're highly mobile animals. They can cover a lot of ground very quickly. One of the things that puzzles me the most is that right whales left the the Bay of Fundy region in 2010, but they didn't start increasing in the Gulf of St. Lawrence till 2015. So what were they doing for 5 years? Were they potentially searching out new habitats? Maybe their distribution was dispersed. Once they find habitats, they really don't have a lot of ability to alert other conspecifics, so individuals of the same species, to these habitats because their sounds don't travel all that far. Their sounds have a range of maybe 40 to 50 kilometers. So they could alert conspecifics that are kind of nearby, but certainly, you know, a whale in the Gulf of St. Lawrence isn't going to be able to tell a whale, you know, outside the Gulf of St. Lawrence that there's good food in the Gulf of St. Lawrence. Once they found a habitat, once they found the habitat in the Gulf of St. Lawrence, it appears to be quite easy for them to find it again. So now we're seeing in the early spring, we see right whales make a beeline, like they aren't even stopping in the Bay of Fundy to check it out. They're just going right up the Scotian Shelf through the Cabot Strait and into the Gulf of St. Lawrence. So now that they sort of discovered this area, it seems like they've got at least enough sort of memory to find that area again, but that's somewhat speculative.
That's great. Thanks, Kim. We've got a good question here from Linda, who wants to know, is this the only population of right whales in the world?
Oh, great question, Linda. Thanks for that. So no, it is not. It is so the North Atlantic right whales are a species, a standalone species. So there are 400 individuals of this species and there are 2 other right whale species, which are in the same genus as North Atlantic right whales. There's North Pacific right whales, and that population exists off of like Alaska and possibly British Columbia. That population is even more endangered than North Atlantic right whales. There's very few individuals left in that population. And then the third one is the southern right whale. And their population has been rebounding since the days of whaling. There's about 20 to 30,000 animals, I believe, now in that population. Those animals are obviously in the South Atlantic. You get them around South America, around New Zealand, sort of that circumglobal distribution around this sort of temperate southern ocean belt. Yeah. So just those 3 species in this genus. The right whales are also cousins of the bowhead whale in the Arctic. So they have very similar feeding mechanisms and very similar prey species that they feed on.
Excellent, thank you. Another anonymous question we have here. Are there any other species that interact with the whales that are impacted by the change in the locations, migrations of the whales?
That's a very good question. I don't know the answer to that. I don't think so. I can't think of any off of the top of my head. There are other, obviously other predators on copepods that would be affected by the decline in copepods in the Gulf of Maine. But there's no other species that I know of, at least none that there's research on, that would be affected by right whales specifically changing their distribution. It's an interesting question.
Okay, great. We have a question here from William, who wants to know, how do the North Atlantic right whales detect their food?
Yeah, we don't really know the answer to that because we don't know a lot about their sensory systems. There's some research on vision in right whales because, they do have eyes, they are visual animals. And they will forage at different depths in the water column, depending on where the copepods are. When the copepods are at the surface, one hypothesis is that right whales will dive underneath them, turn on their sides so that they can see up, and use the silhouette of the copepods above them to identify patches that they want to feed on. It does not explain how they're able to target the animals at depth, and people have put tags on right whales so they can follow the trajectory of the animals as they dive. And then oceanographers have sort of, like me, have gone and sampled the prey field along the dive path. So we know that right whales will dive down, and then as soon as they hit that prey patch, they will turn sort of horizontal and swim and stay within that prey patch in the water column. So they are, like, whether they use tactile senses or smell or what have you to detect those layers, once they're in them, they seem to be able to somehow stay in those layers, which is really cool.
That's great. Thanks, Kim. Let's see. Oh my goodness, we have so many questions coming in. Someone wants to know, are the pods made up of females and calves and the bachelor pods, or is it a mixed group?
Oh, great question. So right whales are solitary animals, so they don't form pods. This is in contrast to something like a killer whale, right? Killer whales, they'll form sort of family groups or pods that will stay together. Right whales are not like that. They travel individually. Mothers and calves will stay together, at least for the calf's first year. And then after that, the calf will be sort of on its own. In some ways, they're not as social as some of them, something like a killer whale. But in other ways, and relative to other baleen whales, they are at times quite social. So once they're sort of concentrated in these feeding habitats, they will get into like courtship groups. We call them surface active groups, and they can have like up to 40 to 50 animals in a group, and they're all just kind of rolling over each other and interacting like physically with one another. And it's really spectacular to see when you're out on the boat. So they do have sort of a social aspect to their behavior that probably helps with courtship and with learning and things like that. But once they're done, then they spread out and they feed individually again, and they travel individually.
Thanks, Kim. It looks like we might have Sean back. Sean, are you with us?
I am, actually. Can you hear me or see me?
Yes, we can see and hear you. Your video is a little bit choppy, but we can hear you okay. So I'll let you guys take it from here. And if I need to jump back in, I will.
Wow. Thank you. Imagine the time if we could ever meet in person again and not have to deal with these types of things. Won't that be something? So anyway, sorry about that. I was going to make up some story about going to visit some right whales while you were talking there, but no, just typical internet service provider issues, I suppose. I'm sorry I missed out on some of what you were talking about and what you were dealing with. Kim, what were you just dealing with?
So we have been answering questions because there are quite a lot of questions in the Q&A
Yes.
Tab there. So I've been just answering people's questions, and there's so many, we could probably easily fill up 20 minutes answering questions if you
Well, that's good, because I know we certainly don't have a whole lot of time left. So I think that makes good sense. You know, but before we jump into the questions, I did want to touch on, I mean, back when before I disappeared, we were talking about sort of the difficulties trying to study these types of things. And I was wondering if you talked at all about the kind of work that you do when you're at sea. Like, how does an oceanographer go about studying giant masses of water that move around in the ocean, or for that matter, you know, clouds of little bugs that live in the ocean that these animals are chasing? How do you want to talk a bit about how you go about doing that kind of stuff? I think that would be fascinating.
Yeah, sure. Just so you know, your video and audio quality are they're not coming through really clear to me. Just so you know, I don't know if maybe you want to turn off your video or what might help with the audio quality. But yeah, so I am a field oceanographer. So I actually go out into these habitats and I study the right whales and other kinds of baleen whales, and I study the oceanography in these habitats. And that's how I have learned about all the information I've given you today, is through going out on boats and using, you know, oceanographics, you know, technology to do this kind of thing. So I'll just show you a couple of last slides here that I've got. Let's see here. showing us out on the boat. I've gone out to sea in the Bay of Fundy and Roseway Basin and the Southern Gulf of St. Lawrence with my lab. This is my lab here, my students and my technicians, and we will go out on usually on fishing boats. So here's one of the fishing boats that we used in the Bay of Fundy this year. And we've got all these contraptions that we'll put in the water. This one right here in the top right corner. This is a contraption that's basically fancy fishing gear for fishing for plankton. And here's us processing one of the plankton samples. Here's us with an aerial drone that we will fly over the whales to get overhead images of them. And it has a thermal camera on it for actually we're doing some experiments to try to see if we can measure the internal body temperature through imaging the blowhole of the whales. So we take teams of people out on these boats. We bring all kinds of technology with us. And we can do that for maybe like 2 or 3 weeks once a year, or maybe twice a year if we're lucky. But that's not going to tell us everything. So we can do these kind of short-term studies. But in order for us to really understand about like the seasonal presence of right whales and how things are varying over longer timescales, we have to go out and put sensors in the ocean that can function without us actually being out there.
Right.
So that's where I use a tool, an oceanographic tool called an underwater glider. And this is a mobile autonomous underwater vehicle, and it's got something called a hydrophone on it for listening for whale sounds. And it's also got this sensor here on it, which will give us like acoustic measurements of the food in the water column. And it'll go out, it's got a modem on it so we can pilot it from shore. It'll go out for 6 months. It'll transit along waypoints, and it'll measure the 3-dimensional distribution of ocean conditions as well as right whale presence in the absence. So we can get data on some of these longer timescales that we can't get with by actually going to sea on a boat. Yeah, so myself, like many other oceanographers, we use a variety of tools and techniques to try to learn more about what's going on in the ocean and what's kind of driving these changes in right whales.
Right. Now, so one of the key things about these gliders is they're listening devices, right?
They are listening devices. That's right. They can listen for right whale sounds and the sounds of 5 other baleen whale species we monitor. Yeah. Right.
Which means there's a bit of a limitation. We can only know that the whales are there if they're actually making sounds, I guess, which is one of the challenges. But also, I guess it's a bit of a challenge figuring out what kind of whale you're listening to when you do hear a sound, right?
Yeah, there's a whole discipline of marine biology / oceanography called marine acoustics or marine bioacoustics that deals with the classification of sounds in the ocean and understanding how sounds change through time, and what's sort of the context for animals producing different sounds, and then how the environment and the human activities in the environment are affecting the animal's ability to produce sounds and communicate using sounds.
Right. Yeah. And so somebody doesn't need to listen to these every time. Is that correct? Like you do have some automation in terms of figuring out which of these animals are, but people do eventually have to listen to them as well, including you, I think, right?
Oh yeah. Yeah. I listen to the audio that's recorded by the glider, many hours of audio, but through lots of decades of research on the sounds that these animals make, there's been lots of opportunity for scientists to develop signal processing techniques for sort of generating sort of automated software to pick out, stereotypical calls that these animals make.
Right. Yeah.
So that's really advanced for right whales because passive acoustic monitoring is such an important tool for conservation.
Right. Anyway, I think that's a fascinating area. It's an area almost, I guess it's not that new, but it's such a new way of studying the ocean and certainly a new way of studying whales as well. So definitely becoming a really important tool as well, in addition to studying the ocean and the water masses themselves that you talk about, right? So that's fascinating. I want to touch on some of these questions that we can get to them. We've got about just under 15 minutes left. Part of my fingers as I try and navigate this thing here. Many of the questions I notice, I do want to mention that we've done a number of these. This is our third webinar. Some of these questions we have answered. We'll try and answer them all here, but take a look at our other webinars that we've done. And in some cases, we'll have answered some of these questions too. So I encourage people to take a look at those. But I certainly don't mind going through them now and talking about some of them with Kim. One of the questions here is whether or not ship noise in the ocean is disrupting sonar and orientation of these whales. You know, these whales aren't exactly sonar users like some whales are, but I don't know, Kim, like, do you hear ship noise on your gliders, and how do you deal with that kind of a situation?
Yeah, there's a lot of research on the impact of noise on right whales, because these animals are dubbed the urban whale, right? They spend a lot of time in areas like around Boston, around New York City, areas where there's a ton of ship traffic coming and going, very, very noisy environments. And right now, actually, there's a natural experiment going on, because with the pandemic, ship traffic has declined in some areas. And I have a colleague at Dalhousie who's published a paper recently showing that this has really it led to a significant reduction in ocean noise in some locations that are usually very, very noisy, like around the Port of Vancouver. Right. And so yes, noise has been documented to cause right whales to increase the amplitude as well as frequency of their sounds, because ship noise tends to be quite low frequency. So that's an effect that has been documented. It would certainly interfere with the animal's ability to communicate with one another, because the right whale call is in the same frequency range as as ship noise. So if there's the communication space would certainly be decreased in some areas where ship traffic would be high. So there is an effect, but whether that leads to like population level impacts, that's something that's really, really tough to infer, especially when there's so many stressors on whales, such as entanglement and ship strike. And, you know, it's hard to disentangle these, what we call cumulative impacts from all these different sources of human activity.
Yeah. That's causing mortality of these animals, but we know that they do react to the sound. They change their behavior, they change their physiology, they increase their breathing rate. They know that the ships are there, and that's another way that we disrupt them, I guess. Yeah. Something else, another question I saw, and maybe we hadn't answered this.
I think you should turn off your video, because your audio quality
is it on?
Yeah, your audio quality is much better when your video is off.
Yeah, well, I do have a face for radio, so I think that's the whole thing. Someone had asked, sorry, I thought it was off. Someone had asked where they go in the winter. I guess we've only been talking about them coming up here to Canada in the summer, but perhaps we should talk about the other part of the year.
Yeah, absolutely. So the Gulf of St. Lawrence is covered in ice in winter, or it's got at least ice flows in winter, and the food is very low. It's in hibernation, and the whales leave. Not just right whales. All species of baleen whale migrate, and humpback whales will migrate out of our waters, blue whales will migrate out of our waters, and they'll tend to go to warmer areas. These whales are kind of snowbirds.
Yes. Yeah.
But something really interesting has been happening since 2010 with right whales. Sort of what we think of as the normal kind of migration pattern, at least for calving females, is that they'll go to the calving grounds off Florida and have babies.
Right.
But as I said when you were off the phone, Sean, as you know, calving has been very low. So we have females that are a lot of females that are not actually going to calve, and so we've been getting a lot more animals sticking around. at least in the Gulf of Maine in winter. Cape Cod Bay is another foraging habitat. It's a foraging habitat, it's just south of Boston. And so it's a little warmer, it doesn't get ice, and it's very coastal, and there's a lot of small copepod species in there, not very nutritious, but really highly concentrated. And right whales go there in winter, and they've been going there in unprecedented numbers.
Right, yeah. And this leads to kind of another question, which is when the whales changed their distribution and they started going to the Gulf of St. Lawrence, one of the things many of us scientists were concerned about is whether or not they would get enough food to actually have babies and have calves, because it's an expensive thing to have a calf or a child, and it takes a lot of investment. And if these animals are suddenly feeding an area that's lower quality, perhaps they might not be able to. So yeah, I mean, you've seen that as well. And I think we've seen that they've started breeding, and this is a good size. So good sign. So clearly they're getting enough food. I mean, this mix, this mishmash of copepods that they're now feeding on is still suitable, I guess, eh?
Well, actually, I would just somewhat disagree with that, because calving remains quite low. I mean, a good calving year for a population this size should be around 20 to 30 calves. Right. And we haven't had more than 10 calves a year in 10 years. So, right. I mean, calving remains depressed. There's some research out of Fisheries and Oceans Canada that suggests that they have actually modeled how much food right whales need and how much is available in the Gulf of St. Lawrence, and found that for females, there's not quite enough food energy to in recent years to support calving. So nutritional stress remains a very big issue, even though the right whales seem to have found a habitat in the Gulf of St. Lawrence.
Right. And we may have seen some clear evidence of that, I guess you're right, because we had a year just in 2018 where we had no calves, actually. And that caused quite a bit of panic among those of us who were thinking of these things too, that perhaps they weren't finding the food they needed. But I guess you're right. They're certainly not breeding at the levels they need to. I'm just encouraged that they're continuing to breed however they can. And maybe that's a good sign. Someone was asking how many of these animals are left. Every year we're kind of delayed a year in terms of figuring out what the population is, because it takes a whole year for us to process all the detections and the photos and everything. And the group of scientists that deal with that just recently released that information, and the number is down to 356, which is a very sad situation. We've certainly been witnessing it.
Yeah, it was up to around 450 when I was finishing my PhD. So, I mean, to lose 100 animals in 10 years is very, very, very bad. I mean,
and it's difficult for us to be witnessing it. I mean, the work that you and I and others are doing, we're in the process of witnessing this and trying to struggle to find ways to make sure that we can make some better decisions so that this doesn't continue,
Yes, we need to be we need to work harder than ever to prevent mortalities and injuries, because nutritional stress remains an issue. And given that the climate is changing in the Gulf of Maine and becoming warmer, it is going to eventually become unsuitable for Callanis Finmarchicus on, decadal and multi-decadal timescales, because the water will just be too warm. And the Gulf of Maine is right at the southern end of the Callanis Finmarchicus distribution. So if the right whales really rely on this region to get enough energy, and all of a sudden that food energy is gone for decades at a time, that becomes a very, very important issue to their conservation. We will not be able to save the species just by waiting for them to have calves again. We have to prevent mortalities. It's more important than ever.
Right. On that point about things continuing to change, is there any work looking at where these, the next food source for these animals might be? Is there concern that these species are going to continue moving north, or is there a way to even predict those types of things? Do you happen to have a career in front of you?
I ponder this.
Yes. Yeah.
to be very forward looking, and predictive, and try to be able to figure out what is next. And what is next is these right whales venturing even further north into what is very much an uninhabited area of northern Newfoundland and the Labrador Shelf. As climate change keeps progressing, that's really the only area that they've got to go, that they have to go, where at least two of the conditions are met. There's Callanis there, and there's a continental shelf, which makes it possible for them to aggregate at depth shallow enough for the right whales to dive. But whether there are these other special conditions that we know exist in like the Bay of Fundy and Cape Cod Bay that I talked about, that sort of collect the plankton into ultra dense patches, whether those exist elsewhere, we don't have evidence of that at this time. I should right now be developing a new research program on the Labrador Shelf.
That's right. Well, and I think the other challenge, of course, we have is perhaps these whales know better what they're doing than we give them credit for. I mean, they know where to go. And the fact that we like to think we know what they're doing is a bit of a bold thing. The Gulf of St. Lawrence, the new area where they're feeding, I think we only ever detect about 120 to 150 individuals in any given year. And there's 350 individuals in this population. We don't have a good sense about where the rest of these are. And that's also a bit of a problem, eh? I mean,
yeah, we can't tag every right whale. I mean, that's something that we know very well. We cannot tag them all. And so there's a lot of unknowns about their distribution and habitat use.
Right. And
go ahead.
Many people ask this question, can we just tag the animals? We can't tag very many of these at all, as you suggest. And even when we can tag them, the tags don't stay on for very long. If people consider what it takes to tag an animal, you catch a shark and put it on a vessel and attach something to its fin, or glue something to a turtle's shell, or put a collar on a caribou. In every case, you need to capture the animal and you need to be able to attach something to it. And neither of these are really a possibility for the whales. So there is some limited tagging ability that we have, but it's really not possible. And that's leading to a real challenge for us.
Yeah, the tagging capabilities are very short term at the moment. You can apply suction cup tags or tags that are that will attach just under the skin to prevent any injury. That's the big issue. You can't just tag a whale with a long, like multi-pronged tag that they use for some of these other marine mammals, because there's just there's too much risk of injury. Yeah.
Right. Well, listen, we've had an hour, and we've taken an hour of your time, Kim, and everyone else's time. And apparently I'm still having connection issues. So what I would like to do is tell everyone we're gonna wrap this up. The questions that you've submitted or you are submitting, please go ahead and submit them. And what I will do is, further impose myself on Kim. And what we'll try and do is take some time to answer these questions on a separate recording. We will release this presentation and the presentation of us answering your questions, and we'll post them both to the Ocean Tracking Network and to the Canadian Wildlife Federation, so people can see the presentation in case they missed it, and it'll give us a chance to answer all of these questions that are coming in and give them the attention they deserve. But for now, I'm going to wrap up this meeting, even though you can't see me, but I'll just have to use my radio voice. And I'd like to thank everyone for coming and attending and for your interest and submitting the questions. Please look out for answers to those questions very shortly. And Kim, thank you for letting me abandon you on this presentation slightly, and you handle it with so much grace and confidence. That's great. And thanks for helping me chat about this, because I think that the same as you, this is a fascinating species, and I love getting a chance to share these stories with everyone. So thanks for joining.
I just really quickly wanted to thank everybody for coming and listening today and submitting questions. It's really, really nice to be able to talk about this stuff with people from across the country. So it's awesome. Yeah. Well, tune in again, everyone. We've certainly not exhausted this topic, and we'll see what we can do when we answer the questions.
Thank you, everyone.
Thank you.
And thank you, Kim.
Thanks. Bye.